I won't be doing limbo on stage. But if you want to challenge me in limbo later, I'm all for it. So I'm very excited to be here. I came all the way from Norway for this conference. It's been awesome so far. Thanks to all of you, the organizers, and the speakers, of course. So now we're going to talk a little bit more about streams and how we've embraced functional reactive programming to build a large single-page application at RDoc. So at RDoc, we try to help businesses answer any question about how their organization is tied together. We do this by modeling them as a graph. So we map out their applications, business capabilities, their infrastructure, and then how it all ties together. It's a fairly client-side heavy app with dynamically generated visualizations, real-time collaboration, and also an interesting mix of technologies that we're going to go a bit into. So for this talk, we're first going to define some concepts to give you an intro to streams and functional reactive programming. Then we're going to hopefully give you some motivation for why you should care. And then we're going to present some building blocks for building an app with RxJS, and also reflect on some roadblocks that we've hit along the way. So functional reactive programming. How many of you have used it before? Please raise a hand. That's a few, not that many. I think I can't see because of the lights, but essentially reactive programming is programming with data streams. So streams that emit data over time. And if you look at the modern JavaScript libraries that most of us use, actually a lot of them embody some of the principles of reactive programming. So in Redux and NGRX, for example, you have the store, which emits the application state over time. So that is essentially a stream, right? What we do in reactive programming, though, is we elevate streams, and we treat them as first-class citizens. And the functional part comes from the fact that we compose them functionally. So we map them, filter, and reduce. There are many libraries in JavaScript for working with streams. And in this talk, we're going to focus on RxJS, which is probably the most popular one. I think it surpassed 1 million downloads this year. And it's also the only dependency of Angular. So RxJS is a library for transforming, composing, and querying streams of data. It implements the observable type in JavaScript, and the observable is essentially a stream. And many people call it Lodash for streams. I think it's quite powerful, though, so I rather like this definition, and I hope you will see that as well. So the observable was made popular in reactive extensions Rx in .NET, I think about 10, 15 years ago. And what it allowed us was to work with async code more easily. And when introducing the observable, I like to compare it with promises, as I think most of us have worked with promises. So whereas a promise emits a single value at a time, observables emit multiple values over a period of time. A promise is not lazy. It begins processing upon creation. So if you create a promise which fetches data, it starts fetching immediately, whereas an observable is lazy. So you can declare an observable that should fetch data from an API, but it won't actually start fetching until you subscribe to it, until something subscribes to it. Yeah. Whereas a promise can't be canceled, observables can be canceled seamlessly. And this can be quite powerful in some web applications. A lot of the core contributors of RxJS work at Netflix, and their canonical example is when a user starts buffering a video and then goes back, you want to cancel the first operation. And with promises, this can be quite complex, while with observables, it's seamless. And kind of reflecting on these properties, I think the more complex our single-page applications become, the more things kind of emit over time. And the observable pattern fits much better for dealing with this than promises. Another reason for why you should care is that the observable is a stage 1 proposal in JavaScript. So it might actually become a part of our language. And RxJS have also done a lot of work in trying to mirroring that proposal. So how did we come across RxJS? We needed to build a separate single-page application. We went with Redux. Then we needed a way to handle async. And for simple applications, you might be fine with Redux Thunk. But if you have more complex data flows, then you probably want to look into Redux Saga or Redux-observable. And we chose redux-observable, and that was kind of our gateway drug to streams. Yeah. So on the left side here, you have a typical Redux application or a Flux-like architecture where you have views that trigger actions. These actions are reduced in the store. Then the views, again, subscribe to the store to read the application state. What redux-observable does is it also adds epics into the mix where we contain our side effects. So epics take in actions and can also read the store, and then they emit new actions. And the store and actions are represented as RxJS streams, so you can apply several operators to them and write fairly complex async code seamlessly. And for us, streams really made sense. So for the actions in store, I mean, they emit over time, so representing them as a stream makes sense. But then if you think of your web applications, you also have click events, DOM events, user interaction, everything kind of emits over time. You can also have WebSocket events. And thinking of these as streams kind of liberates you, as it makes it much easier to model complex data flow. And you might even think of everything as a stream eventually. At least for us, that kind of became the case, and this is our mantra when building applications. And while we were super zen, like this dog meditating, thinking about streams, suddenly reality kicked in. And that's that we needed to fix our core app. So we had built a small application on the side with redux-observable and RxJS, but then we had our main application, which I showed earlier. And it was in a quite dire state with vast amounts of technical debt. So as I said, Ardoc is a startup, and for the first 4 years, we were trying to find product market fit. And what that meant was that we needed to add a lot of new features without thinking much about technical debt or dealing with that. And in the JavaScript world, that also meant that we took a lot of shortcuts, introduced a lot of new libraries, and it led to a mix of paradigms that don't mix well together. We had a new colleague join 2 years ago, and he said that our app basically showcased the history of web development. It had a mix of jQuery, Backbone, handlebars, React, Redux, like all the good stuff for the bad stuff. So it's really hard to reason about what was going on. There was also very little separation of concern. So if you kind of change something over here, this other thing broke. And also state was all over the place. And it was really hard to reason about what's going on. And I think that's kind of where Redux, for example, has saved us, is that it allowed us to think easier about our state. And we were not really there. So the plans for the new architecture was first that we have to re-architecture mid-flight. I mean, we're still a startup. We don't have a lot of developers, so we can't simply build a new app on the side. So we need to start decoupling our app. Then we need to be able to reason about our state. And we also need good interop with legacy state and views. So new views need to interop with old state and old views. And RxJS and Redux was introduced. But then we started thinking, do we really need Redux? And it was great for starting from scratch, but it was not really obvious how we introduce it in a legacy app, especially since we had a lot of state all over the place. Simply adding a Redux store would mean that we had another state manager, so it became an even bigger mess. And if you read the Redux documentation, they mention RxJS, and they say it works well together with Redux. But I want to highlight this one paragraph, and that's where they ask, do you really need Redux if you already use Rx? Maybe not. It's not hard to re-implement Redux in Rx. And that's essentially what we did. So we defined these building blocks, which are very similar to a Redux architecture. It's a Flux-like architecture. We have the action stream, which ties everything together. That is subscribed by the state stream, which calculates the application state based on actions. Then we have view streams, which is a layer in between the state and our views, which prepares the state for the views so that the views can be as simple as possible, essentially pure functions of view streams. Finally, we have routines, and that's where we contain our side effects, so similar to epics and redux-observable. And they also allow us to kind of decouple our application. So we're going to jump into each one of these. So the action stream allows any part of the application to communicate. We define it as a subject. So a subject is a type of an observable. Whereas an observable emits data over time, you can also push data to a subject using the .next method. So essentially, it's a publish and subscribe mechanism. And with these 2 lines of code, we can dispatch our first action and launch a rocket at JSConf. However, nothing is handling this action yet. So for that, we introduced routines. Routines handle actions and produce side effects. So here's an example of a routine. It pipes the action stream, and piping essentially means taking a stream, applying a set of operators, and creating a new stream. And what routine should do is it should eventually emit side effects, right? So what we do here is we filter on the launch rocket action. Then we map that to fetching of coordinates, which could be an API call to get the coordinates. And finally, if that fetches successfully, we dispatch an action to proceed. And these are 3 different RxJS operators. Of type is custom. And in the middle, we have switch map. And I purposefully chose switch map instead of flat map to show cancellation. Essentially, what switch map does is if it starts fetching coordinates, and that takes a long time, and then another action is dispatched to launch another rocket, the first one would be canceled. So that's how cancellation can easily be built into streams. So routines allow us to decouple our application, because modules can simply define what they should react to, and our views and other modules can dispatch actions. So it allows us to decouple them. For us, that helped a lot, because we had basically a spaghetti monster. If one service needed to use another, it basically imported it, and then if that needs to use the other one, then you have circular dependencies. And once everything goes over the action stream, it's much easier to build a modular application. And then we hit our first roadblock, and that was dead streams. So what is streamed may die. Essentially, you need to catch your errors with RxJS. So in this example, if we fetch coordinates and that API call fails, then it wouldn't proceed. And that makes sense, as you would expect. However, if you then try to launch a new rocket, it will not fetch coordinates because the stream is dead. And how you circumvent that is by catching errors. So with RxJS, you need to catch errors in order to keep your streams alive. And that is actually a pretty good feature, I think, because it forces you to catch errors and define how your application should handle them. Of course, for production-ready code, you might want to make it more robust by centralizing stream creation so that you have some global error handlers as well. Next, we have state streams. So far, we have actions and routines, but we haven't really done anything to replace Redux. State streams emit the state of our application. And here is an example of a state stream. So the rocket stream pipes the action stream and accumulates state over time. So if you dispatch an action to launch a rocket, it will decrement the fuel of the rocket. And I think for many of you, this probably looks familiar. It's basically a reducer, except it's now modeled as a stream. And now that it's modeled as a stream, we can also do a lot of different things with them that we're going to go into. So one thing is that we can have derived state. So oftentimes in your applications, you have state which depends on base state. For example, we could have refueling cost, which should be calculated using the fuel price, for example. So here we pluck the fuel, then from the rocket stream, then we apply distinct until changed. What that does is it adds memoization. So essentially, it won't emit until the fuel changes. Then we combine it with a fuel price stream. And fuel price could be defined as an API call. So then when something subscribes to this, it would also do an API call to get the latest fuel price. And finally, we map that to the refueling cost. And normally, if you would have memoization in a Redux app, you would have to add a reselect. While with RxJS, you have operators that can support that. Next, we have proxy state. So going back to our requirements, we have a lot of legacy state. And we need good interop with that. What we can do with RxJS is we can create our own stream creators and essentially stream our legacy state. So what we do here is we create an observable from a backbone model, we define so that whenever a backbone model syncs with the server, it also pushes that to an observable. So then in our new application code, we can simply subscribe to these streams, and they won't really know about backbone being under the hood, so that we can then later swap out backbone easily. So the benefits of state streams is that they're quite expressive and powerful, yet easy to reason about. So going back to this slide, we have memoization built in. We combine it with another API as well, and it's just a few lines of code. And once you get used to the paradigm, it's also quite easy to read. Then it has good interop with legacy state using proxy state. And then you also, once you have your state as streams, you unlock the power of RxJS operators. You could add debouncing. You have memoization with distinct until changed. You could add a buffer. And there are many other options as well. Then we hit our next roadblock, and that's cold versus hot. So I think anyone who starts using RxJS hits this roadblock eventually. For those of you who are not familiar with cold versus hot, it might also be a bit like ambiguous terms. They didn't make a lot of sense to me the first time I heard them. Essentially what they mean, though, is that observables are cold by default, and they can be made hot. So cold observables basically work in the way that every new subscriber gets its own producer. So imagine there's an observable which models the Fibonacci sequence. The first subscriber will get the whole sequence, and then the second subscriber would also get the whole sequence. And that makes sense for some cases. For example, with API calls as well, if an observable is defined to be an API call, you would expect that every new subscriber would do a new API call. However, for some cases, such as state streams, that's not really efficient, because every new subscriber to the state stream would create a new producer. So if we have 5 subscribers to a state stream, it would recalculate the state every time. So what we can do for state streams is we have hot observables. So essentially what that does is that it shares the producer among all subscribers. So basically, cold versus hot is a very important property of streams that has big implications, and you need to kind of think about this when you define your streams. And for state streams, it's easy. We just make them hot. So next we have views, and views as functions of streams. So I think, and I hope most of you agree, that the views should be dead simple, pure functional components. It makes them decoupled from our business logic and easier to change them later. So what we do in our architecture is that we have view streams that pipe state streams and then prepare them for the view so that views can be as simple as possible. And we've created a connect utility function, which works very similar to connect in React Redux. Essentially what it does is it subscribes to a stream when the view is mounted, and then unsubscribes when it's unmounted, so that the view would update whenever the view stream updates. Next, we can also have view streams that fetch data. So you could define a view stream as an AJAX call. So you could essentially fetch data from the API when the view mounts, and map that to props for the view. Using another operator, we could also add initial loading props so that the view could render something before the API call resolves. And we could also catch errors. So with just 5-ish lines of code and maybe a couple of utility functions, we have a view that is coupled to an API call without having that API logic in our view. So that is essentially our building blocks for building an application with RxJS. And now I want to reflect a little bit on the higher level pitfalls and benefits of that. So one thing is that RxJS is extremely flexible. And you need to invest some time in kind of dealing with this flexibility, because you can really shoot yourself in the foot when dealing with it. Another thing is that you might end up with streams all over the place. I heard a podcast with Ben Lesh, the creator or the core maintainer of RxJS, and he warns about basically creating streams all over the place, and that's what many people do. And I'm like, damn, that's the title of my talk. And however, I think you can circumvent that problem by being explicit about your streams and essentially defining your own building blocks. So kind of the building blocks I presented, it's not meant to be a framework or a silver bullet for everyone. It's rather an architecture that you can kind of build to suit fit your needs. And I think RxJS is a great tool for that. Next is the debugging can be a bit challenging in RxJS. Call stacks are a little bit long and hide some important details. However, we have tools to also deal with that. So you can use RxJS Spy to tag your streams. And essentially, then you can also replay your streams. You can stop them, similar to how you would do with Redux dev tools. And the creator is also working on a Chrome extension, so then we'll have a similar experience. And then the benefits of RxJS and streams are also that it is extremely flexible. So you can do a lot of things with the operators that RxJS provides. And I think also one thing is the kind of the expressiveness of reactive programming. You can write 10 lines of code with a few operators, and that defines a fairly complicated async logic, and then it's still very easy to reason about. And perhaps the most important point is that with streams, there is very little overhead to dealing with asynchronous code. Because once you kind of embrace streams, then everything can react to anything at any point in time. So you don't really care about whether it's async or asynchronous. So I think in JavaScript, at least I've heard often that we treat async sort of as a problem when we want to contain it. But with reactive programming, it just becomes seamless to deal with it. So then the question is, should you embrace streams? And I think you should if you find that async code makes things complex in your application. Or perhaps if you're working on a large single-page application and it's difficult to reason about what's going on. That was the case for us, at least. Obviously, adding reactive programming to the mix won't solve your problems, but I really think that it can help you reason about the data that flows through your application. And next is if you're using Angular or redux-observable. I think so. Our Angular has a single dependency, and that is RxJS. But I think many who use it haven't really embraced it that much, so it might be worth reading more into it. And perhaps also, if you use Redux, you should really check out redux-observable. So I hope this talk was interesting, and that you also might start thinking about everything as a stream.